the 7th class of time response analysis. Here the question is, when subjected to a unit step input, the closed loop control system shown in figure will have a steady state error of. So this is the closed loop system given, and this question has been asked in GATE 2005. There are 4 alternatives. So which one is the appropriate answer? So let us see what is the appropriate answer. So here there are two. This is feed forward and this is feedback system. This is a feedback loop and this is a feed forward loop. So let us try to find out its solution by finding the transfer function with the use of signal flow graph. So let us denote first. Let us denote this point. Suppose this point is, this is R given, this is Y given, and suppose this is A. This point, this summing block is A. Okay. Now this summing block is, suppose, B. This is B. Okay. Now this is A, B, and let me now there is no need to write anymore. So let us draw the signal flow graph, and let us denote this point. This point is RS, this point is A, this point is A, this summing block is B, and this summing block is C, and this point is D. Now it is okay. So what will be the signal flow graph for this? So signal flow graph will be as below. So let us draw the signal flow graph. So there are 1, 2, 3, 4, 5, 6. There are 6 points. So here 1, 2, 3, 4, 5 and 6. This point is RS, okay, and this point is YS. Now between RS and A, this point is A, this point is B, this is C, and this is D. So between RS and A, there is a branch. Between A and C, there is one branch. Between A and C, let us denote this branch by like this. Between B and C, there is one more branch. So between B and C, between A and B, there is one more branch. Okay, and between B and C, there is one more branch. Okay. Now between C and D, there is a branch, and between D and Y, there is a branch, and between D and B, between D and B, so there is one branch. Okay. Now let us denote the path gains of each branch. What is the path gain of each branch? Between R and A, path gain is 1. Between A and B, the path gain is 1. Between B and C, the path gain is 3/s. Between A and C, the path gain is 1. Okay. Between C and D, the path gain is, between C and D, the path gain is 2 divided by s plus 2. Okay. Now between D and B, the path gain is again unity, means 1. Between D and Y, the path gain is 1. Now our signal flow graph is complete. So let us see how many forward paths are there. So the forward paths are one forward path is R A. Let us denote this point as A here. Let us denote A as here and B as here. So it will be easier. And C as here. Okay. So one forward path is R A B C D Y. Another forward path is R A. Let us denote here this point as suppose E. Then it would be easier for us. So where is E point E? Let us denote that point E as here. This is point E. Suppose this point is E. Okay. So path gain of this point between A and E will also be 1. Okay. Now there are two paths. First is R A B C D and Y. Second is R A E C D Y. So there are two forward paths, and how many? So let us write the forward paths here. Forward paths. Forward path. Here path gains. Here delta associated with path. Delta associated with path. Now the first path is R A B C D Y. So the path gain for this path is, let us denote the path gain by P1. So P1 is nothing but 1 multiplied by 1, 1 multiplied by 1, multiplied by 3 by S. Okay, multiplied by 2 into S plus 2, multiplied by 1. Okay. So it will be nothing but 6 divided by S into S plus 2. And again let us denote the path gain between E and C. What is the path gain between E and C? It is, since it is minus, so it will be minus 1. Sorry, it will be minus 1. Again here also, since the path between D and A is negative, so it will be minus 1. So it will be minus 1. So here also the path gain will be minus 1. The second path is R A E C D Y. Let us denote its path gain by P2. So P2 will be nothing but 1 multiplied by 1 multiplied by minus 1, 1 multiplied by 1 multiplied by minus 1, multiplied by this minus 1, multiplied by 2 into S plus 2, multiplied by 1. So how much it will come? It will come minus 2 divided by S plus 2. Now what are the loops? So let us see the loops. So the first loop is this one, D B C D. Okay. Let us see whether any other loop exists or not. So A E C D B, and again this will not be a loop. So there is only one loop, because because this is in forward path, this is in not in backward, so we cannot start with here, we cannot start with here also, because here there is no returning path. So there is only one loop. and that loop is D, B, C, D. So loops, let us write here loops, and here loop gain. So what are the loops? So there is only one loop. So that loop is D, B, D, B, D, B, C, D. And let us denote this loop gain by L1. So L1 will be, how much L1 will be? dB minus 1 multiplied by 3 by S multiplied by 2 by S plus 2. So how much it will be? It will be minus 6 by S plus 2. Now we can see, since this loop, there is only one loop and this loop touches both the paths, so delta associated with these two paths will be nothing but 1, because this loop is touching both the paths. There is no such loop which is none touching these two forward paths. So delta associated with delta 1 will be also 1 and delta 2 will also be 1. Now what is delta? So delta is, let us write here. So delta equal to, let us write by red so that it could be clear. So delta is nothing but delta equal to 1 minus sum of gain product of individual loops plus sum of gain product of two non-touching loops minus sum of gain product of 3 non-touching loops, like that. But here, since there is only one loop and that loop is since there is only one loop, so it will be 1 minus L1 only. So what will be this? So this will be nothing but 1, L1 is minus 6 by S into S. Sorry, here it is S also, S is also there. So 1 plus 6 divided by S into S plus 2. Okay. Now we have calculated the value of delta. Now by Mason's gain formula, the transfer function will be, now let us write here. Now by Mason's gain formula, transfer function is Ts equal to nothing but sigma pi delta I divided by delta. So since there are two paths and so P1 multiplied by delta 1 plus P2 multiplied by delta 2 divided by delta. So this will be the transfer function. Now what is P1? So P1 is 6 divided by S into S plus 2 plus what is P2? P2 is minus 2 divided by S plus 2 and multiplied by delta 2 is 1. Here also multiplied by 1 because delta 1 is also 1 divided by what is delta? 1 plus 6 divided by S into S plus 2. Okay. Now it will be the question is asking about a steady state error. So let us wipe out here. So that we can write. So Ts is equal to, Ts will be, if we take S into S plus 2 as LCM, then it will come 6 minus 2S, okay, minus 2 multiplied by S divided by s into s plus 2, here s into s plus 2 plus 6. So these two terms will cancel out each other. So now we are left with 6 minus 2s divided by s into s plus 2 plus 6. Okay. Again it is given that the input is a unit step input. So the input is a unit step input. So now we can write, it is given that input is a unit step input. So we can write here ys divided by rs. This is equal to 6 minus 2s divided by s into s plus 2 plus 6. So this implies ys is nothing but 6 minus 2s divided by s into s plus 2 plus 6. Okay. Now we can multiply it by rs, and since rs is a unit step input, so we can write hence ys is equal to nothing but 6 minus 2s divided by s into s plus 2 plus 6 multiplied by, or you can write here multiplied by 1 by s, since rs is 1 by s. Now the question is asking about the steady state value, the steady state error. So the question is asking about what is the value of a steady state error. So let us find out the value of ys, a steady state value of output. So let us denote the steady state value by yss. So a steady state value of output is a steady state value of output will be yss. This is equal to nothing but limit s tends to 0 sys. Okay. This will be equal to limit s tends to 0 s multiplied by, what is ys? 6 minus 2s divided by s into s plus 2 plus 6 multiplied by 1 by s. So s will cancel out each other. Now if we put s equal to 0, then the numerator will be 6, and if we put s equal to 0 in denominator, then it will also be 6. So it will be 6 by 6. So finally we will get 1. So a steady state error. So a steady state error. Now a steady state error will be nothing but it will be yss, or you can say rs, means rt, or you can say r infinity minus yss. Okay. So r infinity input at infinity will be 1 because it is a unit step input. So it will be 1 minus again 1 because yss, we have got yss equal to 1. So the steady state error will be 0. So which option is correct? So option number C is correct one. The next question is, the block diagram of a closed loop control system is given by the figure. This is the figure. The value of K and P such that the system has a damping ratio of 0.7 and undamped natural frequency omega n of 5 radian per second are respectively equal to. So the question is asking about the value of K. What will be the value of K and P such that damping ratio is 0.7. This damping ratio must be 0.7 and natural frequency omega n should be 5 radian per second. There are 4 alternatives given, and this question has been asked in GATE 2004. So let us try to solve it. So damping ratio is given and undamped natural frequency is given. So let us write here, given that zeta equal to, zeta is damping ratio and omega n, that is undamped natural frequency. This is 5 radian per second. Okay. Now what will be the characteristic equation? So the characteristic equation is given. Characteristic equation for a closed loop system is given by 1 plus GS into HS equal to 0. So the characteristic equation will be the characteristic equation will be 1 plus GS into HS equal to 0, and here GS is equal to, GS is nothing but K divided by S into S plus 2. So this is 1 plus K divided by S into S plus 2 HS is 1 plus SP multiplied by 1 plus SP, and this will be equal to 0. Now this will be equal to S square plus 2S plus K multiplied by 1 plus SP equal to 0. Now if we take S as common, then it will be 2 plus Kp S plus K equal to 0. Now if we compare this characteristic equation by the standard second order characteristic equation, so let us write this equation as equation number 1. So now comparing equation number 1, comparing equation 1 with the standard equation of, with the standard characteristic equation for second order system, and what is that characteristic equation? That characteristic equation is S square, that is by S square plus 2 zeta omega n S plus omega n square equal to 0. We get what we get? We get omega n square equal to this equal to K. This will give omega n equal to nothing but under root K. So now we have got the value of the question is asking about the value of K. So it is given that omega n equal to 5. So this will give K equal to omega n square. So omega n square is nothing but 25. So now we have got the value of K as 25. So this is the value of K. Okay. Now again by comparing these two terms, we can write 2 zeta omega n is equal to 2 plus Kp. Now it is given, zeta is given, zeta is 0.7 and omega n is 5. Here 2 plus K, we have find out K as 25. So it will be 7 equal to 2 plus 25p. Now 25p will be equal to 7 minus 2 equal to 5. This implies p will be equal to 5 by 25, and that will be equal to 0.2. So the value of p is, now the value of p is 0.2 and value of K is 25. So which option is correct? So option number D is correct one. 25 and 0.2. Question is the unit impulse response of a second order system, second order under damped system, starting from rest is given by Ct equal to 12.5 e to the power minus 60 sin 8t for t greater than equal to 0. The steady state value of the unit step response of the system is equal to. So the unit impulse response is given and the steady state value is asking. So given that, let me write, given that the impulse response, the unit impulse response, the unit impulse response is Ct equal to nothing but 12.5 e to the power minus 6t sin 8t. Now if we take the Laplace transform of both the sides, then it will be Cs equal to 12.5, and the Laplace transform for sin omega t is omega divided by s square plus omega square. Here omega is 8, and since e to the power minus 6t is associated with sin 8t, so it will be so s will be replaced by s plus 6. So it will be multiplied by 8 divided by s plus 6 whole square plus 8 square. So 12.5 multiplied by 8 will be 100, and here it will be s square plus 12s plus 6 square means 36 plus 8 square means 64, and we add with both of these terms, then we will get 100. So we have got the value of Cs. So what is Cs? Cs is nothing but it is transfer function Ts multiplied by Rs. So this implies transfer function Ts multiplied by Rs is equal to 100 divided by s square plus 12s plus 100. Here Rs is the Laplace transform of input and Ts is the transfer function. So since here it is given that the unit impulse response, so Rs is nothing but this Rs is nothing but this is 1. So if this is 1, this implies Ts will be equal to 100 divided by s square plus 12s plus 100. Now we have got the transfer function. Now the question is asking about the steady state value of the unit step response of the system is equal to. So now the question is asking about the steady state value of unit step response. So now if the input is unit step input, so let me write here, if the input is unit step input, then the Laplace transform of output will be nothing but, let me denote it by C dash s. C dash s will be equal to Ts multiplied by Rs. So here suppose here R dash s, let me write here R dash s, because we have taken Rs for unit impulse input. Here since the input is unit step input, so we have denoted it by R dash s. Now Ts will be, as we have calculated, so from above it is 100 divided by s square plus 12s plus 100, and R dash s will be 1 by s, because we are taking the Laplace transform of unit step input. So now the question is asking about a steady state value of unit step response. Now the steady state value will be, the steady state value of response will be nothing but C dash ss, and this will be equal to limit s tends to 0 s multiplied by C dash s. So it will be nothing but limit s tends to 0 s multiplied by C dash s, and C dash s will be 100 by s square plus 12s plus 100 multiplied by 1 by s. So s will cancel out each other, and now if we put s equal to 0, so in denominator the term will also be it will be also 100, because these two terms will become 0. So 100 divided by 100, so it will be 1. So the steady state value will be 1. So which option is correct? So option number D is correct one. Now at the last of the lecture, I would like to share one of the most important thing to you people, that if you like my video, then you must subscribe my video, so that there is no need to search out new video. Automatic update will come if I upload the new videos. What you have to do, it is very simple. There is a circular logo coming in right of me. You have to just click on that to subscribe.